Good everyone, my name is Graphics. In this video, we'll be looking at magnitude and direction of resultant force. We'll be looking at concurrent and coplanar forces. Now, if you look at your screen, you see a figure that is displayed on the screen. And the question says, three forces with magnitude 16 Newton, 12 Newton, and 21 Newton as shown in the diagram above. Determine the magnitude of their resultant force and angle with the x-axis, right? And we are given options. Option A is telling us that the magnitude is 7.763 Newton and the angle, which is also the direction or the sense, is giving us 61 degree. Option B is telling us the magnitude is 8.71 Newton and the angle is given to be 61 degree. Option C is telling us the magnitude is 7.63 Newton and the angle is giving us 29 degree. Option D is telling us the magnitude is 8.71 Newton and the angle is 29 degree, right? So this is what the option is telling us. Now let's confirm and see which of the option is the right answer, right? So if you look at the figure closely, is that taken? You discover that the first thing you should try to work on is to see if there is any inclined force associated with the diagram. Whenever you are solving any problem involving statics or any problem at all, and you are seeing an inclined force, you have to resolve. So the first thing you have to do here is to resolve the inclined forces into vertical and horizontal components. So we have two inclined force, which is the 12 Newton inclined at 32 degree and the 16 Newton inclined at 26 degree, right? So let us consider the 12 Newton inclined at 32 degree. Remember, having in mind that this vertical line is the y-axis and the horizontal line is the x-axis. So what you do is you bring out the vertical and horizontal axis out, let them form two perpendicular line, right? That is the x and the y should be perpendicular. Is that okay now? Now, since the arrow you see from the 12 Newton is acting outward, so it means that the forces here will be acting, the lines here will be acting outward. Is that okay now? So I'll put my arrow here and my arrow here. This point here, let me call it point A, and this point here should be what? Point A, just for understanding purpose. Now, one thing you should have in your mind is, as long as the force is inclined to the x-axis, right? The vertical component is 12 is sine and the horizontal component is cos. What I mean is, since the angle is inclined at since 12 Newton is inclined at 32 degree to the x-axis, the vertical component here will be 12 sine 32 and the horizontal component will be 12 cos 32. Have that in mind. As long as it is inclined to the horizontal axis, x, that is x, right? But if it is vice versa, let's say this angle here is placed here, right? And that means it is inclined to the y-axis. That is the force, the angle is in between the inclined force and the y-axis. Now what will happen? The vertical component here will be 12 cos 32 and the horizontal component will be what? 12 sine 32. Get that straight. Is that okay now? So let's go back to our question. So what we're using here, since it is inclined at the horizontal axis, right? That means since the angle is in between the inclined force, the 12 Newton and the x-axis, so we're having the vertical component to be 12 sine 32, horizontal component to be what? 12 cos 32. Is that okay now? Now we will now be looking at the other inclined force, which is the 16 Newton inclined at 26 degree. The same thing apply. Bring out the y and x axis, let the y and s form two perpendicular line coming together, right? And since the arrow is acting outward, that is from point A here, right? Meaning that the arrow here will be going outward here. Is that okay now? So this is what we have here. So the vertical component is 16 sine 26, and the horizontal component will be what? 16 cos 26, which I explained to you earlier. Is that taken now? As long as it's inclined to what? The x-axis, right? Now we've done that. We've successfully resolved the forces. We cannot resolve 21 Newton because 21 Newton is already vertical. And if there's any horizontal, we cannot resolve it also because it's already horizontal. Now, since we've done this now, having in mind, we will not consider the inclined force anymore. We don't have business with what? With the 16 Newton and the 12 Newton. We don't have business. What we're focusing on will be these forces that we've inclined. That is the 12 sine 32, the 12 cos 32, the 16 sine 26, and what? The 16 cos 26. We don't have business with what? This 16 and this 12 because we've already resolved them. Is that okay now? Now let's start our work here. Now recall, for the resultant force for concurrent and coplanar forces, right, is that taken in statics, is given to be the square root of summation of f of x all square plus the summation of what? F of y all square, right? So now we'll be considering to the summation of what? F of x. And what does it mean? F of x means horizontal component. F of x means forces parallel to what? The x-axis. Now the summation means the addition of all the forces act in this system acting along x-axis. And if you look at, we have two of them. One of them is the 12 cos 32 is acting along x-axis, that means parallel to x, and the 16 cos 26 is also what? Parallel to x. Is that okay now? So once you've done that, now if I put it here, 12 cos 32 is positive because the force you're seeing, the arrow is facing the right. Whenever the arrow is facing the right, it is positive. And 16 cos 26 will be negative because the arrow is facing the left. And whenever it's facing the left, it is what? Negative. Is that okay now? Now, if you input it in your calculator, 12 cos 32 is 10.177 minus 16 cos 26 is what? 14.381. And when you do the arithmetic here, your answer for the summation of f of x will give us minus 4.204 Newton. So we've done that for the summation of f of x, right? Now the next one will be for the summation of what? F of y, which means f of y means vertical component, or we can say forces that are parallel to what? The y-axis. Is that okay now? And summation means addition of all the force. And we have two forces that is parallel to the y-axis, that is the forces that are standing. We have the 12 sine 32 and we have the 16 sine 26. Is that okay now? Now when I place it here, and you know one thing, when any force facing upward is what? Positive, and any force facing downward is what? Is negative, as long as what? You are dealing in with statics. Are you with me now? Statics in mechanics, which is an aspect of mechanics. Upward force is positive, downward force is what? Is negative. But if you are dealing with an aspect of dynamics, which is what? Motion under gravity, is that okay now? Or talk about things projectile, any motion under gravity, the upward force will be what? Negative, because it is opposing gravity, and the downward force is what? Is positive because it's what? Is going in the direction of what? With gravity. So don't confuse those two. So we'll proceed. So I'll be having my 12 sine 32 plus 16 sine 26, right? Then remember one here, we should not forget that, which is 21 Newton acting downward. Is that taken now? So minus 21 because it's acting downward. Is that taken? So when we do the arithmetic here, this will now be giving us 12 sine 32 will give us 6.359 plus 16 sine 26 will give us 7.014. Then minus 21. When you do the arithmetics here, you'll be having minus 7.627 Newton. Is that taken? So we move forward. So having these values here, we'll now input it in our equation 1 above in the formula that was given earlier. So we'll now say the resultant force will now be equals to the square root of, we already have the value of summation of f of x, which is minus what? 4.204, right? All square, plus already given the value of summation of f of y, which is giving us minus 7.627 Newton. Is that okay now? So when we move forward, when you square it, we will now have the square root will now have it to be equals to the square root of minus 4.204 square is 17.674 plus minus 7.627 all square give us what? 58.171. Is that taken? This is what we have here. So the square, the negative will disappear because the power is even. Whenever the power is even, means that what? The negative will all disappear, because minus square is minus times minus, and that is what? Plus. So when you add these two together, 17.674 plus 58.171 will give us the square root of 75.845. That's what we have here. And we look for the square root. Now, when we look for the square root here of 75.845, we'll be having 8.709 Newton, approximately 8.71 Newton. That is the magnitude of the resultant force. Is that taken? Now the next thing we should calculate here is the angle. The angle is also referred to as what? The direction or the sense. Is that taken? And for you to get the angle, remember this formula, especially when you're dealing with statics, telling us that what of concurrent and coplanar force is given as tan alpha is equals to summation of f of y all over summation of what? F of x. Is that okay? And we already have the value for summation of f of y and summation of f of x. So for summation of f of y is given as 7.627 divided by summation of f of x is given as what? 4.204. Both of them have negative, so the negative cancel out. Is that taken? Now when you divide both of them, you'll be having tan alpha is equals to 1.814. And if my tan is going to the other side, it becomes tan inverse. So alpha becomes tan alpha. Alpha will now be equals to tan inverse 1.814, because the tan is coming to the other side, right? So my alpha here will now be giving us tan inverse 1.814 will give us 61.133 degree. So that is the angle, which is direction. So if you look at the option, let's see. The first one, my resultant force is 8.71, right? And the angle is what? 61. So the correct answer here is option B. That is for the answer. So if you have found this video helpful, please don't forget to like, subscribe, and also share this video. Thanks for watching.